So it's early 2026, and if you look at the temperature charts for the last 3 years, well, it's sobering.
It really is. 2023 through 25, they didn't just break the records. They kind of redrew the whole map.
Yeah, 2024 came in as the hottest year we've ever recorded, and then 2025 was the third. We're not talking about climate models anymore.
Exactly. We've moved from the era of prediction into the era of observation. The signal is just, it's undeniable now.
Okay, so let's unpack that, because I still see the argument that it's just the sun, the solar myth.
Right, the idea that the sun is just getting hotter.
But the satellite data going back 50 years shows the sun's output has actually, dipped a little bit since the 70s.
And that's the disconnect. If the sun were the culprit, if it were turning up the heat, you'd see the entire atmosphere warm up, top to bottom.
But we're seeing the opposite. The troposphere, where we live, is cooking.
While the stratosphere, the layer above it, is actually shrinking and getting colder.
And that cooling upper layer, that's the atmospheric fingerprint, right?
That is the smoking gun. It proves the heat isn't being added from the outside. It's being trapped down here with us.
Like a blanket.
A very effective one. And the speed of this is what's so jarring. TOT-2 is rising about 250 times faster than it did naturally after the last ice age.
And we know what all that trapped heat does to water. It's not just about temperature. It's about the Clausius-Clapeyron relation.
Yeah, which is really just the physics of a thirsty atmosphere. For every degree Celsius of warming, the air holds about 7% more water vapor.
So you get this whiplash. The atmosphere pulls moisture out of dry areas, baking them.
And then it dumps all of that moisture somewhere else, all at once.
Like we saw in Dubai back in April 24. 3 times its annual rainfall in a single day.
The infrastructure just wasn't built for that. And you see the same pattern in, say, the American Midwest. It's threatening the breadbasket.
Right. The trend is shifting to wet springs and dry summers. So farmers are fighting mud to plant seeds.
And losing topsoil to all that runoff.
Then, come July, when the crops need water, the tap just turns off. I saw projections for 38 to 51 days above 95 degrees Fahrenheit.
Up from a historical average of, 7? It's a huge shift.
Yeah. But, okay, let's pivot. Because we're not just watching this happen. We have frameworks like Project Drawdown. We know where the emergency brakes are.
We do, and it's not always where people think.
Looking at their 2026 list, everyone thinks electric cars, but refrigerant management is massive.
It's absolute critical. We're talking about HFCs, the chemicals in almost every AC unit and refrigerator.
There's insanely potent greenhouse gases.
Thousands of times more potent than CO2 at $2 a time. A tiny leak is a huge problem. So phasing them out gives you this incredible leverage.
Same with food waste, right? Just not throwing away a third of the food we grow.
It's a huge, accessible solution. But there's a new complication that's really exploded.
The AI energy problem.
The AI energy problem. It's the wrench in the works. We spent a decade making solar and wind the cheapest power on the planet.
And now the boom in artificial intelligence is creating this just voracious new demand for electricity.
It's constant demand. Data centers need power 24/7. You can't tell an AI model to just, pause when the wind stops blowing.
So it's a race. We're building renewables faster than ever, but these data centers are keeping fossil fuel plants online just to guarantee that baseload.
A race between a clean energy deployment and algorithmic consumption.
And that race brings us to this really uncomfortable idea of overshoot. It seems like we're almost certain to cross that 1.5-degree target in the 2030s.
The window to stay below it is, it's practically closed. We are very likely going to cross that line, at least for a while.
Which leaves us with the big question for you to really think about. When we hit 1.6 or 1.7 degrees, are we prepared for the transformative change needed to pull the temperature back down?
Or do we just accept that as the new normal? That choice is going to define the rest of this century.
A lot to mull over. Thanks for diving in with us.